is the scattering of light by colloidal particles. Observe this narrow beam of light when I pass it through this colloidal solution.
Wow! I can see the beam of light passing right through the solution.
Yes, that is the effect of the scattering of light. When the beam of light is scattered by the colloidal particles in the solution, its path is illuminated. This phenomenon of the scattering of light is called the Tyndall effect. The illuminated path of the beam is called the Tyndall beam.
Is it only in colloidal solutions that we see the Tyndall effect?
No. You can observe the same even in air laden with dust particles, like in a dusty room. The Tyndall effect can also be observed when a fine beam of light enters a room through a small hole, such as an aperture in a ventilator. This happens due to the scattering of light by particles of dust and smoke in the air. Similarly, when sunlight passes through the canopy of trees in a forest, you can see the Tyndall effect at work again. The mist in the forest contains tiny droplets of water which act as particles of colloid dispersed in air. In fact, here's an interesting incident related to the Tyndall effect. London, in the summer of 1815, frequently saw prolonged and brilliantly colored sunsets and twilights. This was explained by the Tyndall scattering of sunlight by ash particles in the upper atmosphere. These ash particles were produced by the earlier eruption of the volcano Tambora.
Separating components of a mixture by sublimation. Take ammonium chloride, sand and salt in 3 separate watch glasses. Mix all the 3 in a china dish. Plug the base of a funnel with a cotton ball and cover the china dish with it. Place the china dish over a Bunsen burner and heat the mixture. On heating, white fumes evolve from the china dish and rise in the funnel. When the fumes stop rising, remove the funnel from the china dish and allow it to cool. Remove the solid ammonium chloride sticking on the walls of the glass funnel using a spatula and transfer it into a watch glass. Using a spatula, transfer the mixture from the china dish into a beaker. Then pour some distilled water into it and stir the components of a beaker with a glass rod. Next, fix a funnel to a stand with a filter paper in it and place a beaker under the funnel. Then, filter the components of the beaker through a glass rod. Remove the funnel from the stand and separate the sand particles from the funnel using a spatula and transfer it into a watch glass. Pour the filtrate from the beaker into a china dish and place the china dish over a burner and allow the solution to boil till the water evaporates and salt is left as a residue in the china dish. Remove the salt from the china dish using a spatula and transfer it into a watch glass. Finally, label the 3 components transferred into the watch glasses.
This is one of my favorite pens. Look at its color. Not black, but it is dark brown. It raises a question, is it really brown? Let's find out. Let me zoom closer a bit. First, cut the paper down into pieces like this. Do not use tissue roll and box tissue. Chromatography paper and filter paper are the best for paper chromatography experiment, of course. If you don't have these paper, like me, you can use white multifold dull paper, because it is thicker than normal tissue paper. Then, use a pencil to draw a dashed line. This line is called starting line. Draw a dot with your pen on the starting line, and make sure that the ink is water soluble. Now prepare a tube. Pour some water into a tube. And put the paper down into the water. The starting line should be above the water level. You can use a clamp for holding the paper. Wait for some time until the ink stops moving forward. Water moves up the paper by capillary action, which occurs as a result of the attraction of the solvent molecules to the paper. As the solvent rises through the paper and dissolves the sample mixture, which will then travel up the paper with the solvent solute sample. Different substances in the sample mixture travel at different rates. Besides, paper is composed of cellulose, which is a polar substance. The substances that are attracted more to the paper will move very little, while the substances that are more attracted to the water will travel with it. In this case, different substances have different level of attraction, so the substances can't be separated. It seems that the ink is separated into 2 colors, red and green. Take out the paper carefully, and do some analysis. Place a ruler next to the paper to do some measurements. In paper chromatography, we usually calculate the RF value. The ratio to front value is defined as the ratio of the distance traveled by the substance to the distance traveled by the solvent. So the RF value of the red ink is 1.9 divided by 6.0 and the green ink is 3.8 divided by 6.0. This concludes that unique components have unique RF values. You can use different pens to separate different color ink and calculate the RF value. Thanks for watching.
ratios when broken down. Simplest substances on the chemical change. All these are elements of our life. Your substances, that's right. Not broken by physical or chemical. Say all types of elements are metals, and classified not metals, or could be metalized based on properties. Mixtures combine them two or more, keeping characteristics their own, where they can be separated. Some physical means like evaporation. Mixtures of compounds or elements. Sometimes there's more of this or that, and proportions can be different by how it is mixed about. Compounds are made of elements, changes are chemical. Mixtures are made of both, physical will separate. All these are elements of our life. Your substances, that's right. Not broken by physical or chemical. Say all types of elements are metals, and classified on metals, or could be metalized based on properties. Solution, single substance with a solute and solvent. Solution, do not settle, can't be filtered or scattered like concentration. Is the measure of solute dissolved in solvent. Solubility is the amount of solute to saturate solutions out. All these are elements of our life. Your substances, that's right. Not broken by physical or chemical. Say all types of elements are metals, and classified not metals, or could be metalized based on properties. Oh yeah, classified matter. Listen, suspensions could take particles. They're large enough to settle out, be filtered and blocked or scattered like a heterogeneous mixture. Colloid particles won't settle out, too small that they won't filter now. These mixtures particles are big enough above to scatter beams of light.